Thank you, and thanks for the invitation back to talk to the, what is it, the North Wales Ambulance Society or something? In which case, I think I've got the wrong talk. Never mind. This is a short talk. I'm working by that clock, and by 8 o'clock I'll be done when those... So this is the lighter side of astronomy. And I assume everybody is sort of okay with this level of maths, yeah? We're going to start from there and then ratchet it up a bit, yes. The bit you can't see, you mean? The doodle. That's not a doodle, that's a collapsing molecular cloud or something. Yeah. So I've talked to NWAS before, but given that this is a talk about the lighter side of astronomy, what I first need to do is, although I'm familiar with some of you, I need to calibrate your sense of humor so I know what to say for the rest of the talk. So first, one slide of calibration. So a spiral galaxy walked into a pub, and then the landlord threw him out saying, "You're barred." Okay, right, that's the calibration done. 1/3 of you thought it was funny, 1/3 of you thought it wasn't funny, and 1/3 of you didn't understand it and had to have it explained to you that there is such a thing as a barred spiral. So now I've gauged exactly where you stand. I know what to do for the rest of the talk. So it's a little bit about astronomers, a little bit about telescopes, a little bit about observatories, and given that by then that clock will be reading 8 o'clock or 8:15, I'll stop there. So I've got miscellaneous, but I don't think I'll go beyond astronomers, telescopes, and observatories. So astronomers. Some astronomers are scientists. I'm an astronomer and I'm a scientist, so you think you have what it takes to be a scientist?
Well, we just don't know.
But that's sort of what's going on in my head all the time, pretty much. I always have equations rattling around in there, even when I'm doing other things. And of course, some astronomers are scientists and some astronomers are astrophysics, and that's a wonderful way of making sure people get turned off astronomy by actually trying to explain the mathematical aspects of how the universe works. And so, okay, given that none of you sounded very enthusiastic, we won't be dealing with the mathematical side of how astrophysicists deal with the concepts of astronomy. Looks like we're just clipping the top there, but I guess that title is still legible there. Okay. HR diagrams. Some of you might know about Hertzsprung-Russell diagrams. It's how we classify stars. If we were to plot all the stars that we know about, essentially the ones in our galaxy, and we were to plot them with the X scale being the temperature, so for some ridiculous reason, hot is on the left and cold is on the right, and there's the temperature scale of the surface temperature of the star. And if we plot luminosity up the y-axis, we find that the stars in our galaxy don't scatter randomly all over the place. There's a structure there. There's a main sequence which tells us about stellar evolution. At the top, we have giants and supergiants, and at the bottom, we have dwarfs. Okay, that's not funny. That's just a statement of fact. That's how stars are classified. But somebody once said, well, if astronomers classify stars like that and produce a diagram where you plot every star against 2 of its properties, why don't we do that for astronomers? And somebody came up with a Hertzsprung-Russell diagram for astronomers, in which the X scale is not temperature. We can't have color, because that would be very non-PC to have the color of the astronomer. Instead, we have the scientific output of the astronomer. And again, just like the Hertzsprung-Russell diagram, it runs leftwards. So scientists that have 10 published papers, scientists that have 100 published papers, etc., 1,000. So left to right, or right to left, is how scientifically well-respected this individual is. And up the vertical scale is luminosity, not in the sense of how many watts per square meter a star is generating, but in terms of luminosity in the social media sense, the visibility of said individual, the fame, which can easily be quantified simply by Googling their name and seeing how many hits you get. So scientists want to be over on the left-hand side of the HR diagram, because that is where respected scientists live. Media stars or TV presenters want to be as high as possible, because that gets them a lot of Google hits. So I'm hoping you can't read this, but who do you think that is in the very top left corner, the individual that's the furthest top left, the most prolific? Okay. Okay, that's one. Anybody else take a guess? No? Okay, right. Yeah, that is Carl Sagan. Carl Sagan has produced many hundreds of papers, and he is essentially as well known as you can get, partly because he was around for a long time, and although the youngsters sort of know the name, still, if you Google his name, you will find you get, I don't know, 1 million hits or so. Right next door, Stephen Hawking, okay? Arguably more famous because his star is just a little bit higher, not quite as many papers, but still well over 100. If you come further to the right, that's where Brian Cox lives in this particular diagram. He is almost as famous, and he's got 10 to 20 scientific publications to his name. Not as prolific as Hawking, not as prolific as Carl Sagan, but almost as famous as far as the world is concerned. I don't quite understand why this individual is there. It's underneath not quite 1, because you can't put 0 on a log scale. This person, as far as I know, has no scientific publications, but is well known. I presume because, in this case, she has presented a number of astronomy programs. I guess more on American TV than in British TV. That's Mylene Klass. So that gives you a sort of calibration. Non-scientist on the right, very respected eminent scientists on the left. And other individuals you can see, Neil deGrasse Tyson, Chris Lintott, Professor Jocelyn Bell Burnell. And there's a crowd of people to the left of Bell Burnell. There's a whole lot of people, well-respected scientists, people like previous Astronomers Royal, produced lots of publications, not so well known to the public compared to other individuals. And I thought this was interesting. There's the main sequence where you have a lot of unnamed individuals, and you have dark astronomers down here. These are the astronomers that produce some interesting scientific papers, but nobody's ever heard of them, so they're well down on the diagram. Given that this is Google hits, which is easy to find out, and given that this is scientific papers, I'm an astronomer and a scientist. I don't tend to publish scientific papers in astronomy, but I thought, well, in principle, I can be quantified by both of those things. I've written about 100 papers, and I thought, I wonder, everybody at some point ends up Googling their own name. If you Google Steve Barrett, you find lots of Steve Barretts in the world. Unfortunately, there's a few Dr. Steve Barretts as well, so that doesn't help. So I Googled Steve Barrett, University of Liverpool, to try and make sure it was me rather than anybody else. And I got about between 2,000 and 3,000 results. I looked at the first few to make sure they were me, not some other individual interloping as me. So that means on this diagram, if I were to plot me, it would be Google hits of a couple of thousand and about 100 papers. I'm in the main sequence. There you go. I'm not a supergiant. I'm not a media star. Basically, it tells me what I've known all along. I am a totally mediocre scientist because I'm right there in the main sequence. If this was the Hertzsprung-Russell diagram for stars, the sun would be a little bit over to the right, but there I am, certainly on the main sequence. If I continue publishing papers and if I continue gathering a few Google hits, I may crawl a few millimeters along that line, but I'm not going to go very far at my time of life, I don't think. But at least I didn't fall into the dark astronomers rather than in the media stars up there. So I thought that was interesting. Why limit HR diagrams to only stars? Why not put people up there as well? Where did astronomy start? Well, certainly cavemen or before. This particular individual can't quite understand why this big log here doesn't produce a higher magnification moon than any of the smaller logs that are obviously completely hollow. So he's having a little bit of a concern there. Is that the most powerful log you have, he's asking, because that's costing $8. I don't know how you get dollars that early in cavemen history. Notice there's a small telescope on the left on a tripod. There's a small telescope on the right. Notice it has a finder log tied to its side to make it easier to find a star before you look through the main log. But what I find interesting about this is not only the fact that they're looking through hollow logs, just like kids will look through toilet rolls to look at the moon and pretend it's a telescope, but you can tell that the guy on the right with the coiffured hairstyle is obviously the salesman. He's wearing a tie. Of course he's the salesman, you can tell. So despite the fact they're wearing whatever animal furs, you can still point out the used telescope salesman rather than the customer. And of course, astronomy has been around a long time. I'm not sure when the first sundial came into use, but in this particular case, perhaps you can't read that too well, it says sundial repair, because the sundial repairman has been called out because this customer, as you can see on the left, has been observing that his sundial was working fine. Then he had a solar eclipse, and then the light came back again, but once the light returned, his sundial just started blinking 12 o'clock. And so he had to call out the sundial repairman to come and basically fix it. And we all know that there are monoliths around, big stone circles, etc. In the UK and elsewhere, we're familiar with that one that's a sort of caricature of Stonehenge. We presume it's a clock, we presume it's a calendar. These things were great, except that one of the architects is talking to the other guy saying, remember, at the end of summer, we have to give everything a slight turn to the left to make sure it accounts for BST. And this individual is trying to understand, this is not necessarily an astronomical monument, but when you think about how all these stones are moved around, one is asking the other, we've got no idea how it was that these large stones were moved. How did they do it?
Well, we just don't know.
But what they're missing is the fact that on the left-hand side, they're missing a clue as to how these stones were moved. And there it is. So we've had ancient astronomers who we don't know much about, and of course we've had more recent astronomers in the last few centuries, and we can recognize those. I probably don't need to tell you who they are. Let's just have a quick look at what this chap did. Of course, didn't necessarily invent the telescope, but used the telescope in the very early 1600s. And of course, he was a very good scientist as well. He tried to understand how gravity worked. He went to the top of the Leaning Tower of Pisa, alleged, and dropped cannonballs off. And the wisdom of the time is that heavy objects would fall faster than lightweight objects, and he dropped a large and a small cannonball and showed that they hit the ground at roughly the same time. But it's difficult to get the timing very accurately when all you're doing is watching or measuring time by measuring your pulse, for instance, which is what Galileo did as a timing object. And some people have said, would science have been advanced if Galileo didn't have to guess the timings but had access to computers? What if there were computers in Galileo's time? Well, it wouldn't necessarily have made much difference, because instead of dropping cannonballs, he would have probably just dropped computers off the top and then see whether the Mac or the PC hits the ground first or something like that. So it might not have made any difference. Newton, of course, had other things to say about gravity. He came up with the universal theory. How did he discover gravity? How did he think about gravity? Well, the apocryphal story is he was sitting under a tree in the orchard outside Woolsthorpe Manor, and whilst he was sitting there musing, an apple fell on his head, and he started asking himself, well, why did the apple fall rather than go sideways or go up? So that story that Newton discovers gravity sitting under a tree is well known. What is not often appreciated is that later that same afternoon, Newton discovered comedy. And some people believe that later that evening, it got really weird when Newton discovered surrealism. I like the way the apple goes bouncing out in this particular case. Carl Sagan, of course, well known for his TV series Cosmos, in which he was wonderfully enunciating the billions and billions of stars that exist in our galaxy and the billions and billions of galaxies that exist in our universe. But perhaps as a kid, he wasn't quite so eloquent, and one person's idea was, just look at those stars. There must be hundreds of them. Maybe that was the limit of his imagination back then when Carl Sagan was a kid. People, of course, have been building telescopes. The professionals have been building telescopes for a long time, but it's very interesting to see what amateurs do. That, I'm not sure if that ever existed. This looks like a very fanciful design of a telescope back in the Victorian era, I would guess. And for quite a long time, very gifted amateurs have been building their own telescopes rather than assuming that somebody else in a commercial enterprise will build them and then you just go out and buy one for yourself. Here's one amazing looking telescope that apparently was made by one individual, and it's not simply made of nice shiny metal. It's made of titanium, which is one of the most difficult metals to machine and ridiculously expensive. So I'm not sure how much that would have cost. It looks absolutely fantastic, but you do wonder if that's just made to make it look like bling rather than to make it actually as a perfectly functioning telescope. And there are many thousands of amateur telescope makers out there. Some produce wonderful telescopes, and some just haven't got a clue what they're doing, basically. But if we look at the smallest telescopes in existence, fork-mounted telescopes. Some of you might have a fork-mounted telescope. Yeah, some might not. Some might have German mounting. Fork-mounting telescopes you tend to think of as being relatively large objects, but in fact you can get a small fork-mounted telescope. And there it is, there's the fork, there's the knife, and there's the spoon. And quite how they got it through the tines of the fork, I don't know, but I think that is functioning, and it has the advantage that the knife, fork, and spoon actually make a tripod as well. So isn't that fantastic? Isn't that a wonderful way of doing it? Somebody else claims that they've got probably the best telescope in the world, and from that phrasing, you can probably imagine what it's made of. Yep, a Carlsberg beer can. So Carlsberg can, a small mirror, probably no smaller than the one Newton had in his reflector, you know, maybe about an inch or so in size, and an eyepiece with a little 45-degree mirror on the end of it. I'm told it worked. I don't think it was the world's best telescope, but I think it did actually work as a telescope. So again, kudos for the people who are thinking outside the box in terms of how you make yourself a telescope. For some individuals, one is not enough. Why build one telescope when you can build a pair of binoculars? Look at that. Essentially, two Dobsonians side by side in a mount, arranged such that the eyepieces come together at the right interocular distance for a person. The real disadvantage, of course, is what you're looking at is behind you. So in terms of actually trying to point at something, I think it might be a little tricky to use. But for those that like the 3D experience of viewing with both eyes open, that must be the ultimate way of doing it. I'm not sure what the size of the mirrors would be in there, perhaps 10-inch, but somebody wanted to go one better and produce binocular telescope with something of order 18-inch mirrors, I guess. But given that the eyepieces are up here, again, that cannot be the easiest thing to use. So again, one wonders whether they're doing this to show off to their mates rather than to actually make a practical thing to go out into the dark and actually use. But I guess if it's set up right, it must produce some phenomenal images of deep sky objects. For some, one isn't enough, and for some people, two isn't enough. Some people have gone down the road of saying, not how big a telescope can I afford with the amount of money I've got. Some people have gone down a different road, especially, for instance, some universities that want to buy a telescope but haven't got enough money for a big telescope, so they decide to build it up slowly. You go out and buy yourself a commercial 400mm lens, such as this Canon 400mm focal length f2.8, a very nice lens, very good aberration correction. You put yourself your choice of CCD camera on the back, and you've got a very nice imaging system. Why should you use that compared to a telescope with a larger area to gather light? Well, you can buy more than one of them, and if you wish, you can put 10 of them together. As long as you've got a mount that's big enough to hold the weight of 10 of these beasts, you have 10 telephoto lenses and 10 cameras on the back. You're taking data in parallel. You don't wait till one exposure is finished before taking the next one. And of course, if you wish, you can have each camera with a different filter. You can have them all taking H-alpha, or you can have half of them taking H-alpha, 3 of them taking oxygen, and another one taking luminance. You have choices as to how you arrange your data acquisition. Generally speaking, they're all pointing at the same object rather than all pointing to different parts of the sky. It has the advantage you can build it up slowly. You can buy yourself 3 of these when you've got the money, and if more money becomes available the following year, you buy another one, and next year you buy another one, and you build it up. This is what was done by the University of Toronto. They built it up slowly until they had 10, and then they found, by looking behind the sofa, they found more money and decided to buy some more, and they ended up with 24. At this point, they started calling it the Dragonfly, for reasons that you can sort of understand by looking at that. I believe they've gone beyond 24, but not all on the same mount. I think they've now got 2 lots of 24 on 2 separate fork mountings, because it simply gets overloaded if you try and put 48 all together. But even 24 of these with 24 cameras all working in parallel is an amazing instrument for taking data quickly. And indeed, they've made some scientific discoveries by pointing that at particular chunks of sky, which either the professionals don't bother looking at or is not well suited to professional surveys. So if one isn't enough, go for 24. That's one way of doing it. Not cheap, but it means you can build it up slowly. And we all know that size matters in terms of either trying to collect as much light as possible or the largest possible mirror or lens to give us the best resolution of whatever objects we're trying to either look at or image. And some people have taken that to sort of extremes. This is an amateur who lives somewhere in America, I can't remember. I would imagine that's a dark sky site, looking at the fact that it's on the side of a mountain and there don't seem to be any signs of population anywhere in the background. Can you imagine using that in the pitch dark? Can you imagine actually climbing that step ladder and then finding you can't reach the eyepiece and coming all the way down again and moving it slightly over? So it cannot be the easiest thing to use. I'm not quite sure what the size of the mirror is. I'm guessing 24-inch or maybe a little bit more, maybe a 30-inch or something like that. So again, it must produce stupendous views of various objects, but I can't imagine it's actually a very easy telescope to use in practice. But that's what some people do with their money. I'm not judging, I'm just saying that's what some people do. And of course, if size does matter, then you can ask yourself, well, what's the largest refracting telescope? We know there are very big reflectors dotted all over the world. I used to think the largest refracting telescope was the 40-inch at the Yerkes Observatory in Wisconsin in the USA, until I realized that this thing existed in the Great Exhibition in Paris, a telescope that was so large it couldn't move, so it was bolted into the horizontal position, and to look at different parts of the sky, they had a movable mirror, a bit like solar telescopes used these days. A movable mirror here would direct light down the telescope, and here's a cross-section of the building it was in, a movable mirror at this end, a large static telescope, and then film or eyepiece at the other end. And during the Great Exhibition, this was used, I believe, during the day. The sunlight was reflected into the telescope, and then you had eyepiece projection to produce a solar image in a huge theater where, I don't know, a few thousand people would sit and look at this live image of the sun, where they would be able to see sunspots and other features on the surface of the sun. I'm not quite sure if it ever got used at night.
But isn't that actually a reflector?
No, it's a 43-inch lens. That's only there just to get the light into the telescope. It's actually, an objective is sitting there, and you can get its size, roughly speaking, from the person sitting next to it. So it's essentially almost a copy of the Yerkes telescope. Yerkes was a 40-inch, 1 meter lens. This thing is just a little bit bigger, and hence was the largest refractor ever built. You can see what's at the business end. If the objective lens is there, at the other end you have an eyepiece. That gives you an idea of what it looks like to look down the building. The objective lens is at that end, and here's the photographic plate holder. Looks to me to be about 2 foot square or something. I have not seen photographic plates taken with it, so I guess it didn't really produce any interesting images of night sky objects. Otherwise, we would be more familiar with what this thing could actually do. Notice that if you want to focus, this thing moves in and out slightly, and hence it's on wheels to make sure that you have a little bit of focus. And if you wanted to, you can replace this cylinder with a photographic plate holder with a cylinder which is the eyepiece holder. Now, I'm not sure how big the eyepiece would be. I've not seen a picture of the eyepiece, but that's where the eyepiece goes. That gives you an idea of the size of this particular beast. My understanding is it was built for the Great Exhibition, 1900. And I think once the exhibition closed, the telescope was scrapped, which is a bit of a shame. They realized that you can't ever point it other than in the way shown here. And they also realized the quality really wasn't quite up to scratch as a scientific instrument. So interest waned. The metal was, I think, just sent for scrap. The lens is sitting in a museum somewhere. I don't know what happened to the rest of it. So not exactly an amateur telescope, but interesting that the largest refractor ever made, in a sense, no longer exists. It's not the Yerkes in Wisconsin, though that's the one that is still thought of as the largest working telescope of its type. You don't have to build telescopes out of metal, of course. You can build them out of wood. If you wanted a scale model of the Hubble telescope in wood, you can do that. In this case, the scale is 1:1. Somebody decided that they would like a model of the Hubble, and they have a very big workshop, and they decided, oh, what the hell, let's not build a small-scale model, let's make it 1:1. Why? I have no idea, but this is what some people do with their spare time. Perhaps that's what you do if you've got too many cloudy nights. You just decide to build yourself a full-size replica of the Hubble Space Telescope. Other people produce wonderful telescopes in wood. So, for instance, this Dobsonian, I think it's a Dobsonian, not a Canon. It's difficult to tell from this particular angle. But it looks like a beautifully made piece of an instrument. And again, when you look at the amount of work that's gone into these, you start to think, well, yes, that's a very interesting scientific instrument, but it's also a piece of art. It's just wonderfully made. Some people decide to buy optical tubes and then make everything else out of wood. So here somebody has decided to make an equatorial fork mounting themselves, but they've kept an OTA, an optical tube assembly. They've decided not to grind their own mirror and make the tube out of wood. They've decided just to go out and buy that. So optically, it's probably as good as you'll get, but he's decided to make everything else himself out of wood, which is an interesting angle to take. And again, in terms of this, the difference between a scientific instrument and something which is just a beautiful work of art, Russell Porter, the amateur telescope maker, who had a big input to the Hale telescope, also made small telescopes on the side, and that is a wonderful telescope. It's, I can't remember where it is actually in terms of which garden it's sitting in. A small mirror at this end, a little 45-degree mirror at the top, and a small eyepiece. It works as a telescope, but it's designed to be a conversation piece sitting in the middle of somebody's garden. What a wonderful work of art that is, and it's reflective of the sort of genius and the thinking of Russell Porter himself in terms of making telescopes that aren't purely functional, but can be, if you wish, very decorative as well. So we can see the craftsmanship that's gone into that particular telescope. Some individuals put equal amounts of craftsmanship not only into their own telescopes, but some amateurs do the same into their observatories. And again, you've got to acknowledge the genius of anybody who tries to make an observatory dome out of wood and makes it as a geodesic dome, rather than say, oh, it's just easier to make it out of fiberglass or something like that, or to cheat. No, this person seems to have taken the difficult road, which produces a wonderful result of a geodesic dome made out of triangles of wood, and even the shutter itself matches the shape extremely well. I can't quite judge the size. You sort of have to judge it either by the flowers or by the hinges. So I'm not sure what size telescope this would take. And of course, some of us might have observatories in our back garden. Some of us might lust after the idea of having an observatory in the back garden. And there's only one disadvantage of this. It's wonderful to have somewhere where you can go and the telescope is already set up. But your garden might not be a dark sky site. It might be that your garden is convenient because you walk out of your back door and there's your observatory. But that's not much use if your garden happens to be floodlit and you live in suburbia or in a city. So what you really want to do is to be able to take your telescope out to a dark sky site. But then you have to leave your observatory behind. Isn't that a bit of a shame to take a telescope and have that sitting in your back garden? So some people thought, well, yeah, I want an observatory, I want a dome, but I want to be able to take it to a dark sky. But of course, there's no solution there. Well, actually, yes, there is. I don't think you can buy these. I think they have to be custom built. But yes, you have a caravan with a dome on it. You don't often see that, I would admit. You don't usually see that going down the M6. But think how convenient that would be. You tow it to wherever you want your dark sky or your festival or your star party or whatever. You do your observing, and when you're done, you go to bed. And halfway through your observing, you go to the kitchen and make yourself a cup of tea and then back to the observatory again. And you can do all that from within one vehicle. How fantastic is that? It might be that you have a car, but you don't relish the idea of towing an observatory around as big as that. Maybe if you've got a small car, you like the idea of having a dome that's mobile, but you don't want to have to pull anything that heavy. Is there a smaller version of that? Well, yes, there are smaller versions of that. Maybe that's a little too small for most people, and I'm not sure if that actually jacks up, etc. I've not seen that thing extended, so whether that's it or whether there's more to it, I'm not too sure. But from the looks of it, anybody can drag that around. No, but if all you've got is an 8-inch telescope, cat or something, that might be the only sort of size you need. You're not going to get in there as well, but if it's only an enclosure for the telescope, that might be okay. And if you don't like the idea of dragging one of those around, then maybe you want a telescope that can be moved around easily. Maybe you've got one that you just put in the back of a car. The alternative is you basically get yourself a telescope on wheels. And so I'm not sure if you need a license to drive this or not. I'm not sure what powers it. But there it looks like somebody who's taken something like a standard Dobsonian type design and has customized the hell out of it so that you end up with something which, again, I'm not sure what powers it. It might be a remote control device, so you just go down the road and this follows you as you go down. But that's what I call a real go-to telescope. That will go anywhere, basically. Look at the size of the tires on that. That will go pretty much anywhere you want it to go. The earliest example of a real go-to telescope I could find in terms of mobility was this refractor sitting on top of a car from, I can't remember which year this is, the 1950s, I think, where you have this rather handsome astronomer showing off his pride and joy. I looked at that and thought, well, that can't be right, because the telescope surely can only sort of look at the horizon. It can't look very high in the sky if it's sitting on a car roof. Well, actually it can, yes, because there's a crank handle on the side, so you can rack it up. It looks like the post goes all the way through the car. I'm not sure if it hits the ground, so if it does actually rock on the suspension, that's not too good. But the implication is, well, maybe it's usable. I think it's an 8-inch refractor or something like that, and you can see the focal length there, quite a few meters. So if that worked as a telescope, that would be a fantastic amateur telescope. I wasn't sure if this is a publicity photo, a publicity stunt on the part of the telescope manufacturer sticking it on a car, or whether it's a publicity stunt from the car manufacturer putting a telescope on the roof. I couldn't quite see the logic either way round. Does that convince you that you want to go out and buy one of these things? I mean, nobody in their right mind would put a telescope on top of a car. That is just a crazy idea. Unless you're an American, in which case it's a perfectly sensible thing to do. And here's an individual from, I think it's Florida, where he's put his telescope on top of a Volvo, hence the Tele-Volvo. In this particular case, he has some slow motions to help him move in, it looks like Altaz, when he's down at the business end of the telescope. And notice he has some supports under the rear bumper, presumably to stop the car suspension moving backwards and forwards under the weight of this telescope as it slews around the sky. I figured that that must be the largest telescope that is mobile. And with the exception of that one, I think it is. This is SOFIA, the stratospheric observatory for infrared astronomy, where an infrared telescope is in the back of a 747. Not many people can afford that, with the exception of NASA, by the looks of it. The idea of buying your own 747 and custom fitting a telescope in the back compartment, I guess you have to reserve that for the professionals, and I don't expect any amateurs come close to having their own 747. Though might happen one day. There's some billionaire somewhere who might want to go with it. You never know. So, given that we've now got to the limits of altitude and ludicrous telescopes, I think that's a good place to stop. So with acknowledgements for the places where I've judiciously ripped off cartoons or taken things from the internet. If you want to go explore these for yourself, there's lots of other astronomy-related jokes there if you want to go and have a look. Thank you all very much.